Hello friends, today I will discuss about short circuit test of transformer. Purpose of short circuit test. In short circuit test, normally impedance voltage is applied in either side of the transformer by keeping the other side is shorted. That is, if the percentage impedance of the transformer is 6%, then normally 6% of the rated voltage is applied in either HV side or LV side by keeping either LV or HV side is shorted. If impedance voltage is applied in the LV side, then HV side should be shorted. As rated current flows in both the side of the transformer, so in the short circuit test we can find out the total I square R loss or copper loss of the transformer. As the voltage applied in the transformer is very less, in short circuit test the core loss of the transformer can be negligible. Now consider rating of a transformer is 10 MVA and HV side voltage is 33 kV and LV side voltage is 11 kV and percentage impedance is 8%. So 8% of rated voltage is applied in LV side by keeping HV side shorted to circulate rated current. Here rated current means HV side full load current is MVA capacity divided by root 3 into HV side voltage, which comes as 175 ampere, and rated current in the LV side is 525 ampere. So as the percentage impedance is 8%, so applied voltage in the LV side will be 8% of rated voltage, that is 11 kV, which is equal to 0.88 kV or 880 volt. If supply is given is the HV side, by keeping the LV side shorted, then the applied voltage shall be 8% of HV side rated voltage, which is equal to 8% into 33 kV is equal to 2.64 kV. Now arrangement of the short circuit test for 10 MVA 33 by 11 kV transformer has been given in this diagram. Here the HV side, that is delta side or HV side, is shorted, and the LV side the impedance voltage is applied by means of pulse generator or by means of 3-phase variac. You can see the wattmeter input is taken by means of the secondary of the ammeter and the secondary of the PT voltage as connected in the phase. So W1 is the wattmeter reading for red phase, and W2 is the wattmeter reading for yellow phase, and W3 is the wattmeter reading for blue phase. And the PT red phase, yellow phase, and PT blue phase has been shown in this diagram. As the percentage impedance 8%, so 8% of rated voltage in the LV side is enough to circulate the full load current in both the side of the transformer. Now here the supply voltage is 8% of 11 kV, that is equal to 0.88 kV or 880 volt, and full load current in the HV side is 175, and full load current in the LV side, that is ILV FL, is equal to 525 ampere. Since applied voltage is only 8%, the wattmeter reading is mainly of the I square R loss or copper loss, that is W is equal to the sum of the 3-phase wattmeter reading, that is W1 plus W2 plus W3 will be equal to the total I square R loss or copper loss of the transformer. Since W is equal to W1 plus W2 plus W3, which is nothing but the total I square R loss of the transformer in terms of the CT secondary and PT secondary. So this wattmeter reading must be converted to the primary side by multiplying into a multiplication factor, which is nothing but the CT ratio into PT ratio. since all the current is taken to the secondary of the current is taken to the wattmeter, and secondary of the PT voltage is taken to the wattmeter, so this current and voltage multiplication factor should be multiplied to get the actual value of the I square R loss, that is in terms of the primary value. So W dash equal to W into multiplication factor is the actual I square R loss in terms of the primary value of the transformer, which is equal to W into CT ratio into PT ratio. So as the I square R loss is W dash, so R the total equivalent resistance referred to the LV side, which is given by R is equal to W dash by I square. Now the total equivalent impedance referred to the LV side is Z equal to V supply by I. Now the V supply voltage is known, the I is nothing but the rated current in the LV side, so the value of the Z is also known. So from the value of the Z and from the value of the R, we can get the total equivalent reactance referred to the LV side, X equal to root over of Z square minus I square. Now X is nothing but X equal to J into omega L. So we get the value of the R and L, that is equivalent resistance and equivalent inductance referred to the LV side in short circuit test. Now similarly, how does the short circuit test of a 2.5 MVA 15.75 kV by 575 volt DYN5 vector group is DYN5, that means HV side is delta connected and LV side is star connected, and LV side induced voltage of each phases is lag by that of the LV side by 150 degree. So the diagram has been shown of DYN5 and percentage impedance is 6.23%. So how to short circuit test of this kind of transformer can be done? So here the HV side full load current is IHV if FL is equal to 2.5 into 1000 by root 3 into 15.75 kV, that is HV side voltage. So which comes as 91.64 ampere, and LV side full load current is equal to 2.5 into 1000 by 1.732 into 0.575, which is equal to 2510.3 ampere. So in this case the impedance voltage shall be applied in the HV side by keeping LV side shorted to cater the full load current in both sides of the transformer. Here impedance voltage means 6.23% of HV side rated voltage, that is 15.75 kV, which is equal to 0.981 kV or 981 volt. So if we apply 981 volt in HV side by keeping LV side shorted, then full load current will flow in both the side of the transformer, and the wattmeter connected in the secondary side of the CT and PT will show the total copper loss of the transformer of red phase, yellow phase and blue phase as discussed earlier. Similarly, the total wattmeter reading should be multiplied by the multiplication factor of the CT ratio and the PT ratio, which are used in the HV side to get the actual value of the copper loss in terms of primary value. So friends, if you like my video, then do subscribe my channel, and thank you for watching.